This conference will now be recorded.
And as far as the services are concerned and the end users are concerned, it also leads us to ask the question, a little bit about the question, who is an end user? Well, to kind of put this in the right perspective, the end user has been for a long time the likes of me and you. The end user in legacy systems has been another individual. They may or may not have been on a mobile phone, but the services were quite easy to define, and service provision was provision to a customer. The customer could be a small business customer, but the services themselves originally were in legacy systems were very simple, very straightforward. Services such as a voice service. If there's a voice call service, then the connectivity would be between one user and another user through a variety of network elements. Some of you may be familiar with MSCs. There are circuit switch call servers, and as a consequence of the call taking place, certain charging events could trigger information being sent to a charging system. So the source and destination numbers, the duration of the call, any special charging rules that there might be. And of course, when we talk about services, we have to consider that a service provider doesn't just do this for fun. They do it because they want to generate some revenue. So we have to consider these aspects. Another common service would be a text-oriented service, where during the sending and receiving of some kind of message, again, there'd be network elements in there which might help facilitate the service in terms of, in this instance, an SMS platform which can store and then forward the message. Each link between the source and destination would need to be connected appropriately and carry the right quality of service for a text message. So service-oriented parameters need to be considered. And again, charging events could trigger some kind of billing mechanism. And if we talk about a data service, well, in mobile cellular networks for a long time, and it's still very much the case at the moment with 2G, 3G and 4G systems, the data service will transit through a number of routers. Those routers might have specific names according to the system that they are part of. So here I've got an SGSN and a GGSN, or a serving gateway and a packet gateway pair. And once again, there'll be charging events. And the charging events could be a little bit different from kind of voice and text, because this might be in terms of quality of service, throughput, reliability, and so on. But in addition to that, these quality of service parameters would be more, I won't say fixed, although there is the potential to modify these quality of service parameters. They tend to be relatively static and relatively fixed. So that the services that were being provided, it's quite easy to see in older systems how the services will typically be provided to individuals, and the mechanisms for providing the services were quite straightforward. If we then move on to the evolution of services from 3G to 4G, and then from 4G we'll move on into 5G. Several of the key aspects of service provision evolution, as in the move from 3G to 4G, were facts such as the radio access network, the RAN, became predominantly IP based. So very little in terms of circuit switch technology and much more packet switch technology in the radio access network itself. The core network became more IP based. This allowed for a much flatter network architecture. And the moment you have a flatter architecture with less of a hierarchy, you have more flexibility in how you might provision servers which provides either some feature of managing mobile networks or some feature of providing services themselves to end users. There was a lot of work in terms of optimizing the user plane, making it much lower latency and a higher throughput. There's year on year there are improvements to latency and throughput capabilities. More intelligence in the control plane, giving a more flexible approach to both the core network and radio access network elements, becoming more and more server oriented. And if you have a distributed IP based architecture, then you can have a multiplicity of network elements that perform the same role, but having these being accessed according to load and congestion and speed and such like. And another aspect of the evolution of service provision with the move from 3G to 4G is to make quality of service control much simpler. Now, one of the challenges has been that the moment you introduce new techniques, someone comes up with new applications, and those techniques or new network architectures, and those techniques are no longer optimized. And this has been the story of mobile telecoms from day one, and this will continue to be the story. But what it does mean is this evolution path brought many benefits, but didn't complete the picture for network operators to still to make the kind of revenues that they're looking to make. When I said earlier about having a flat architecture, so the EPS, the Evolved Packet System, which is the fourth generation LTE architecture, the Evolved Packet System has got a much flatter architecture. We don't have a hierarchy of network elements. We have a small number. On the left-hand side of this diagram, we have some number of base stations called eNode Bs. On the right-hand side, we have either a service platform to provision the service, or access to some external networks such as the internet or a corporate intranet, for example. And in the middle, a number of gateways, a much flatter architecture with IP connectivity throughout. Now, another aspect of the evolution of 3G into 4G, which had some success, but again, it hasn't completed the picture yet, and 5G kind of adds to this. Another aspect is the fact that quality of service is managed more effectively in 4G than in 3G, but still has lackings. In a 4G system, we have, for example, in this diagram, on the left-hand side of the diagram, we have a device. The device has a connection which we refer to as an LTE bearer, which connects to the serving gateway, the central box in this diagram. Of course, it connects via the radio node. It connects to this central box, and that serving gateway then routes the content to a packet gateway. And content coming from the network, for example, the internet, routes from the packet gateway to the serving gateway, and so on down to the device. And we have these two separate components. And collectively, that path gets referred to as an IP, Connectivity Access Network Bearer, IP CAN bearer. Now, a big improvement and enhancement that occurred with 4G is that the moment you switch on your device and register with a network, one of these connections becomes available to you, rather than only having it when you have a device, a data path requirement. However, the amount of signaling and control messages that's required to set up these IP CAN bearers and to set up multiple of them for a single user if they have multiple services, that signaling requirement can be quite onerous. It can be quite a burden on the network, especially if the bearer then isn't used for very much. It's signaling without any kind of return for the network operator. When it comes to quality of service, there are very strict rules in place. And what I mean by that is that downlink quality of service is enforced at the packet gateway, and the packet gateway is quite away from the end user. Uplink quality of service is enforced at the node B, the base station. And again, that can be quite a distance, both in terms of number of nodes and in reality, in terms of latency from the edge of the network. But 4G network doesn't allow this, any changes to this. There's very limited breakout possibility on that link into the network, and there's no breakout possibility at all on the link between the serving gateway and a packet gateway. But this was an improvement over 3G, but still had some lackings. And I think one of the things that highlights what the lackings are, one of the ways to think about this is that these days service providers are different. If we go back 5, 10, 15, 20 years, service providers all offered very similar services, service types: voice calls, some kind of messaging, internet access, and then they may well offer enterprise-oriented services, but they were very limited in their scope. And what this has meant, along with the huge uptake of mobile devices that there has been in the past 20 years, means that providing services just based around phones and smartphones has got very limited growth potential, because most of us already have at least one. So there's got to be something more than just selling a phone or a data package. Network operators are changing what they offer and how they offer it. They need to be able to differentiate services. The service platform needs to be much more agile. They need to develop new charging models, and all these things are taking place. And I'm sure that many of you will have heard in the past few years that the Internet of Things market, the machine type communication market, and the vehicle to vehicle market are prime candidates for 5G growth and for 5G service use. But not every network operator will offer the same package of IoT. Some network operators might not get involved in the vehicle to vehicle market at all. Some markets, some network operators and service providers may totally deal with IoT and do very little for consumers. And this is going to be a consequence of whatever licensing agreements there are, but licensing models will be different as we move forward through the next few years. So that means network operators can't have the same style of network as their neighbor, as their competitor, because they may well be offering different services. So if I just show you briefly a high-level view of the 5G service-based architecture, this is the next evolution of service provision architecture. Data itself is more accessible in this central region, which is the core network. We don't have the equivalent of a bearer. It makes service provision much more flexible. So I'm not interested too much in talking about what the individual network elements here do. We talked about that a little bit in a previous webinar. Here it's more about the fact that the architecture is more flexible, is less rigid, and doesn't only have to support IP-based working. It could be Ethernet-based working. It could be unstructured working. So there's a lot more flexibility in place for service provision. And that allows techniques such as network slicing to take place. When we talk about network slicing, we're essentially talking about different combinations. I'm just going to go back a slide. Different combinations of the network element here being used for different services, for different end customers or end groupings of customers. So rather than having a very strict relationship between one part of the network and the network elements that get used for all services, there's a lot more flexibility with the network providing collections of network elements for different services, but in the same area. So here there are 3 different slices that I'm showing, where the protocol stack that can be used for each slice would be different. The radio access technology, that's what RAT stands for, could be different for different slices, but some similarities from one slice to another. And the network nodes that get used to provide these features between two slices might be the same, but between two other slices might only have some similar attributes or some similar nodes in use. But that would appear like the network, well, it would appear as if there are, in this instance, 3 different networks in play, but actually there's one network that's been sliced differently for different service types or use cases. So I'm just going to pause there and just ask if anyone's got any thoughts or questions on anything so far. So Maha's asked the question, what is UPF? UPF is user plane function. So if I kind of come back to this diagram, the user plane function is whatever the function needs to be to support routing or forwarding of data flows in one direction or the other or both. So for example, if it is purely passing IP packets to and from the internet, the user plane function will be a router. But it will be a router that is managed by the control plane, which is those network elements above in this diagram, which would give it the appropriate rules. So user plane function is a kind of generic term, and the network operator would need to provision this as required for the different services. Okay, so I'm going to move on from this and talk a little bit about service platforms. It has been in the past the situation that a service platform would be a big commitment for a network operator in terms of provisioning, installing, maintaining, upgrading, and so on. And service platforms would commonly be specific to a service, such as a messaging platform. However, a few years ago, a more flexible service platform came in called the IMS, the IP Multimedia Subsystem. And this more flexible platform allowed for quality of service management for different IP-oriented services that were very much media-oriented. So voice calls, if you make a voice call on a 4G network now, it is highly likely that the connectivity is being managed through the IMS platform that the network operator has. It's standardized, it uses a protocol called SIP, Session Initiation Protocol, but that protocol has been modified to fit the needs of mobility and mobile network operators. So this is a more flexible platform. As a consequence of this, part of the evolution of service provision meant that you could then have bundled service packages more effectively that were IP based. So this was a step in the right direction for network operators, but this didn't really change anything about the radio side or the mobile network key architecture. It was about the platform that was then accessed. And IMS has evolved over the past 6-7 years and provides a lot of flexibility for network operators, but it still really has provided flexibility for the same types of services that the network operator would previously offer, but in a more manageable way. It doesn't really facilitate new services. It's all about media, multimedia, voice and video oriented services and some messaging kind of stuff. I'm not going to spend any real time on the IMS architecture, other than to point out on the left hand side of this there's a circle with the words access network in there. The IMS architecture is independent of the access network. And the big the big bonus there was that you can have an IMS architecture for your 4G network as a network operator in order to support voice over LTE, and make that IMS architecture available to your 3G and 2G network and available to your 5G network. Okay, so voice over a 5G network can easily run through an IMS platform in the same way that it does over a 4G network or a 3G or 2G network if required. And this IMS core is essentially managed through a bunch of SIP servers, and the SIP servers provide the connectivity. Now, evolve it, if we take that as just one service platform, the evolution of 4G was that we have these service platforms. IMS is one example. Policy and charging control, that's what PCC is about, is another example of a service-oriented platform. And the applications and services themselves, well, as 4G evolved, not to 5G, although this is a principle that's used in 5G, but through various evolutions of 4G itself, there became less control in the radio access network in terms of resource management. There isn't a centralized radio resource management server like there was in 3G and 2G. But what's happened as a logical evolution of that is that more and more networks have baseband pools close to the edge of the network, so close to the radio towers, the node Bs, but not directly placed with them. It allows for remote radio heads, which give much, they're cheaper to install and manage, and you have a lot more flexibility of radio resource management as a service. Well, it only makes sense then, as you evolve to 5G, to take that kind of architecture and deploy applications and services right at the edge where the baseband servers are, not necessarily on the same servers, but in the same, with the same kind of logical architecture. Have a service platform presence, a multi-access edge computing presence very close to the end users. Doing this makes a huge change in service provision. It means there's more requirement for higher throughput right at the front end, less requirement for higher throughput on what they call the backhaul, because on the backhaul, users who are using the MEC services, their traffic isn't transiting to the backhaul, it isn't transiting to the core. And this reduces application latency. So this is one method of providing much lower latency services to end users. And what we find is that this is built into the 5G specifications. So 5G networks are designed to support this from day one. It's up to the network operators if they deploy it, but the service provision architecture is built around the assumption that this will take place. Another aspect then, which becomes very, very relevant when we're talking about service provision, is that if the following things are true, the network operators want to hit new markets because they want to make more money, because they can't just sell to me and you more and more and more. That doesn't cover the costs of rolling out their 5G networks. So if the network operators want to hit new markets, and there's a lot more flexibility in how they might provision the network, and this becomes much more IP oriented and software oriented in terms of servers and access network flexibility, then what we find is that the skill sets to support that kind of working, those kinds of architectures, come more from a cloud architecture background. And what we are finding is there are a lot of changing roles in the service provider space these days. Companies that previously we might have considered internet service providers are moving into the mobile network domain. Mobile networks are moving into the ICT domain because the architectures and services that they have to support hit more than just mobile end users. They hit enterprise services. And so network operator roles are changing. I keep getting pulled up for calling them mobile network operators, where really we ought to be calling them these days digital communication service providers. So one thing that cannot be avoided is the recognition that more and more end users, irrespective of whether they belong to a corporate, whether they are individuals, whether they're working from home, more and more end users want bigger and bigger big buckets. The number of users globally that have got less than 10 gigabyte packages per month has decreased massively. The number of users that have got between 10 to 25 or 25 plus gigabytes per month in their data allowance, irrespective of how they pay for it, but bundled up in their data allowance, the number of users that have increased, the number of gigabytes per month has increased massively. And this takes us much more into the digital domain in terms of managing that and providing appropriate services that are going to keep customers engaged and with a network operator, but also that allows these service providers to target other markets. If their architecture is more server oriented, cloud oriented, it lends itself to this idea of digital transformation. And I'm not going to say a lot on this slide, that you'll be able to read a lot of this for yourself when if you get the package from Sarah. But essentially, it's digital transformation is about transforming not just what you convey in terms of ones and zeros, but how you manage your business. And a lot of this in the mobile network domain is through virtualization, through mobile edge computing, through cloud virtualization, through software-defined networking. Telcos need it in order to generate more revenue using less resources. And what it means is that the roles of who provides what has become quite blurred because new business models are emerging and different organizations play into those new business models. 5G can support a multiplicity of use cases, but there are a small number of primary areas that are expected to, or that are being addressed now initially. One of them is enhanced mobile broadband. So taking the broadband that we already have on our mobile devices and making it faster, making it slicker, making it higher throughput. High throughput and lower latency, speed and latency are two different things. Making it more reliable. And that allows for greater content to be provided. And although network service providers don't particularly just want to keep aiming at consumers, the regular consumer, and offering them bigger packages, they do have to consider that as well as their other offerings. Otherwise, they'll lose out to other providers that do offer bigger packages and lower latency and higher reliability. Then there's in the central column here, the actual capability to support what they call URLLC, ultra reliable low latency communication. But network operators are looking down looking at the route of offering that to enable more specialized services. For example, autonomous vehicles, they clearly need ultra reliable low latency communication. There's an argument that enhanced mobile broadband doesn't need ultra reliable low latency communication. It requires some aspects of reliability and some aspects of low latency for some services. So providing those in two different models of monetization. And then the massive machine type communications and Internet of Things. It's a different set of service provision requirements. Something to consider. What many people instantly think when they talk about connectivity for machine type and IoT working is that oh yes, it's temperature sensors and it's some surveillance cameras and it's pressure sensors that have got little bits of content to send now and again, and they're not always very busy, so that can't be too difficult to manage. And for the communications aspects, that may well be true. But for the management of devices and the management of registration and security, this becomes a huge task. You know, having several thousands more devices in one cell than if you've just got voice and data users is a real challenge. It's not about managing the actual data throughput, but managing connectivity and registration and security themselves. And that obviously takes a different business model, because you cannot charge successfully for numbers of bits in a day and make any money out of it if the devices hardly send any bits in a day. But you still need to put a lot of effort as a service provider into managing connectivity. So it needs a different business model. And this all lends itself to service providers having service platforms with different APIs that can be used to communicate with the service platform. And the service platform is not a server, it's a collection of services that provide connectivity to each other to determine what's the appropriate service to supply the end user, but also how does the network operator allow different kinds of organizations to interact with their service platform. If I'm a mobile network operator, maybe I want Google to be part of the service offering that I offer, and I allow them to access my service platform. If I specialize in providing IoT to automated manufacturing process plants, then I want those companies to be able to access my service platform directly. From a management perspective, for example, it's not the same as providing internet access. So the service platforms look more like the service platforms that you would have, for example, with Amazon Web Services, where many, many different kinds of customers interact with their service platform. And indeed, they offer software as a service and infrastructure as a service. And this becomes something which becomes more realistic within the 5G era for mobile network operators. And it also means that there's the potential for developers to provide innovation by having access to the network to develop and roll out services on behalf of the network operator. And of course, there's the consumer-oriented products such as TV and messaging, which come kind of hand in hand with offering a mobile service. So this looks very, very different from a 2G, 3G, and 4G service provision platforms such as IMS, because there's a lot more flexibility and agility required out of this platform. When you start to look at what some of the options are for communication service providers, okay, so I've got a question from Nathan. DSPs, digital service providers, the CSPs, communication service providers. So these are companies that provide services in slightly different ways aimed at slightly different audiences. But the idea is that the network should, or a 5G network operator, 5G network service provider can offer their services to other users, other groups. So if I was to take an example of a network operator that has developed their own service platform, and that service platform, the way that the 5G architecture is specified, that service platform has got what they call microservice servers in there. So there might be a policy server in there, there might be a security server there, there might be a content server in there, there might be a registration server in there. But this all exists on commercial off-the-shelf hardware. The mobile network operator will then utilize some of those resources to offer their own services. But at times when they are not so busy, those resources, the computing, the networking, the storage capabilities that those resources have could be offered to third parties. So the network operator becomes a cloud service provider. Just kind of moving on there then, in terms of communication service providers themselves, their options are really to either gradually roll out some 5G in small incremental upgrades, or to build an extensive 5G network to get a leading position before they start to, to build an extensive 5G network in order to command a leading position, getting extensive coverage, very, very dense number of cell sites, high number of cell sites, and deploy the new capabilities of the network very early. And there are advantages and disadvantages to both of these, and we're seeing both of them being rolled out. It makes more sense for a greenfield operator who comes into the 5G space. Perhaps, oh, so we need to mute that video, please. Thank you. It takes a new greenfield operator who doesn't already have a network out there cannot incrementally add to their network because it doesn't exist. Whereas an existing network operator may want to add some kind of 5G service provision, maybe fixed wireless access to provide businesses, enterprises with mobile broadband, or enhanced mobile broadband to end users. If the service provider provides that, they can do that. If they've already got a 4G network, they can do that in a more incremental fashion. So we're seeing both of these kind of rollouts taking place. Certainly, CSPs need to meet certain demands. They need to be much more agile operationally. It isn't just about being able to utilize their architecture in a more agile way, but to run their business in a more agile way. I can recall when new service platforms were coming in, such as IMS. It would take 6 months to a year to implement a new service because of all the architecture considerations that there were, but also because of all the billing mechanisms and the customer service models that were in place. And so operational agility needs to be improved. Using critical features such as ultra low latency is a key aspect for many types of services. So network operators CSPs need to know how to sell that. That's a challenge for them, how to sell into markets that they are not used to selling in. There's a different requirement for the vendors, and by vendors here, what I'm talking about is the vendors of the network infrastructure. So the companies, for example, like Ericsson, like Huawei, like Alcatel, like Nokia, Siemens, these companies that provide the service providers with their equipment. Of course, now these days, the Ciscos of this world too, that they provide the network operators with their equipment. They need to be more engaged. They're not just selling equipment and then planning a network. They've got to know a lot more about what their customers, the vendors' customers, are the service providers. They've got to know a lot more about what their plans are and create technology that supports their plans, their roadmaps for 5G and for 4G too. They need to develop a much deeper understanding of what the customer owns, what their assets are, what their customer service strategies are, because they can no longer supply a one-box-fits-all kind of solution, because the flexibility and the agility that are required by the network operators mean they need a greater range of service capabilities, therefore different combinations of platforms of equipment types. I'm just going to say a few words now on some of the service provision opportunities. And by this, we're talking about opportunities that are outside of the realms in which, or the arenas in which network operators have dealt with for a long time. Media and entertainment companies becoming much more involved with companies like the Netflix of this world, like the Amazons of this world. Much of the initial growth in 5G will be driven by consumer entertainment experiences which can be improved by 5G. Consumer entertainment, even down to 5G for the home. Many networks out there are offering 5G packages idealized for the home environment, so home entertainment, home security, home smart metering via 5G. This can be facilitated through the capabilities that 5G provides. Again, lower latency, network slicing, and edge computing, moving the users and the content closer together. Enterprises themselves, they're seen as a huge opportunity for network operators to provide the enterprise space with software as a service through 5G, with networking as a service through 5G, with a platform as a service through 5G, with IP telephony through 5G, but for a particular enterprise. And so that a challenge there again for network operators is that there are several challenges are that there are other low power radio technologies out there available, like Bluetooth, like Wi-Fi, like LoRaWAN. They're all likely to serve as well as 5G for some services. And they're not just going to disappear. So 5G network operators have got to coexist and compete with these other solutions. And as networks themselves, service providers themselves are using cloud models for their own purposes, then using cloud-based connectivity and cloud-based services is an ideal opportunity for 5G network operators to offer their services, to provision their services. Other kind of markets which require a change in how an operator provides their services and a different kind of business model are things like vehicle connectivity, vehicle to vehicle, vehicle to infrastructure, vehicle to person, fleet management, entertainment, safety, automated vehicles. These are all 5G oriented, or these are all applications that 5G services could support. Smart cities, the idea that the waste management, the water management, the traffic management, the lighting management, the security, the service management could all be done, could all be provided using 5G, or a large amount of it could be provided using 5G, but having to manage that and having to sell that as a service provider into a local council or government organisation is very, very difficult, because these are huge projects. These are projects with 5-10 years of rollout time to be considered, and mobile service providers, mobile network operators are not used to dealing with that. Decentralization of healthcare. We're all experiencing some of this, I think, with the current COVID situation, where it's less easy and less desirable to go and visit the hospital or visit the doctor, but having more than just a Skype call to have your consultation. To have features such as limbs that are monitored via a 5G network. There are networks out there at the moment, AT&T, for example, in the US, they can monitor and troubleshoot prosthetic limbs using 5G technology. Well, at the moment, they're using advanced 4G technology, but because their 5G network wasn't strong enough at the point that they rolled this service out, but the principle's there. So I'm going to move into this last section. I'm just a little bit aware of time. We've got about 12 minutes, 10 minutes left, and I think we're quite good to allow some questions at the end. So when we look at service provisioning itself, there's a new look to how this is, how this might work, and it's based really on how do you differentiate services, how do you cater for IoT and other very different types of services, how do you support them, and how do you optimize on a network. So quality of service differentiation in 5G is different to that of 4G. I mentioned that in 4G, it's much about defining policy at the edge of the network and at the radio node and just making sure that flows flow according to that quality, a given throughput, a given reliability, a given latency. Whereas in 5G, we have a great distinction between the control plane, which manages access and manages sessions, along with many other attributes, and the user plane, which just routes. But some key differences here are you have quality of service flows rather than bearers, and these are more flexible. Every packet, if it's a voice packet, but every datagram that gets sent is marked with a quality of service marking, which allows any network element to understand how to treat it. Quality of service flows can be very short-lived, and that's attractive, because it means you don't have to have a long session of setting up all the parameters to manage a session if there's only 2 or 3 packets to send and receive. So the quality of service is very, very different. Each node becomes, if you like, application aware and can react more dynamically to quality of service requirements. And there's much less overhead in terms of signaling and control messages. When we talk about IoT, well, IoT is just really another dimension for services. We've had any time and any place for a long time. Now, anything, human to machine, machine to machine, machine to human, thing to thing, these have got all these different flavors of endpoint. I'll just call it endpoint, not necessarily device. But all these different aspects of endpoints need to be catered for by different service support mechanisms. And when we look at that, we can see that 5G can provide connectivity for massive numbers of things because its service provision mechanisms can be slimmed down to a very minimal for certain types of services. The 5G platform can support many different form factors. It could support smart cities, remote control for process automation, all these kinds of things. But it's very difficult to optimize every one of these if you have a very rigid service platform. So my point here really isn't about what can be offered, it's how can you optimize many, many different aspects of service delivery when they all pull in different ways. What you can't have is a discrete set of optimized nodes for every different service. Otherwise, you'd need thousands of nodes within the network to support those services. So what is more realistic when we consider that the next generation core, a 5G core, isn't only going to support 5G next generation radio access, it's also going to support 4G and 3G and 2G and IMS and fixed line and vehicle and all these different kind of service mechanisms are required. So 5G is capable of support or can be designed to support that. And the only way that works really, and I'm going to finish with this slide, is to have cognitive management and optimization, self-organization, so the network becomes aware of what's taking place and how to optimize for services and how well services are actually running. This is possible as a consequence of this microservice architecture. And essentially what we're saying is that the network can generate its own intelligence, can dynamically scale based on activity profiles and services that are being used, and can be more flexible in terms of diverting services to just where they're needed and optimizing access. Maybe optimizing access might be delivering a service through a combination of 4G and 5G when you're in certain areas, or limiting a service or enhancing a service when you're in other areas. This is, in the core and application world, able to be supported by having a programmable core. So the core network shifts and changes through being virtualized and software defined according to the needs of the radio access network. The access network itself can be agile by coordinating multiple technologies. And the air interface can be very, very flexible. The radio connectivity can be very, very flexible by having multiple antenna points acting as one cell, so we'd call that a virtual cell, coordinating these and optimizing the protocols for different applications. And the general idea would be for this cognitive management is that analytics taking place drive decisions in the core to then optimize the service, optimize for a device, optimize for the type of access, optimize security, whichever protocol is needed. And this becomes an iterative process. And that then means that the service platform is service centric. It's not designed around a single platform or bringing multiple platforms together. It makes the services optimized and managed according to the needs at the time. And that gets me to the end of this webinar. Thank you for your attention and a couple of questions that were in there. I'm just going to throw it open now to see if anyone else has any more questions. And we've got 2 or 3 minutes left to do that. I'm just pausing a little bit longer because I know sometimes it takes a while to, if you're going to ask your question via the chat window, it takes a while to type that in sometimes. Okay, well, look out for the next webinar that will be advertised by Sarah. I hope you found some of this useful. If you message Sarah, she will be able to send you the PDF of this. Thanks very much for your attention, and I will see you, or you will hear from me next time.
Thank you.